In this lesson we're going to review those 2 points of concurrency that you know, and then also learn a couple more. So the first one that we're going to talk about is the circumcenter, and you should know by now that that is the point of concurrency of the 3 perpendicular bisectors, and it's also the center of a circle that is, the point is equidistant from the 3 vertices. So if I were to sketch that, and I want to, again, all I can do is kind of sketch here. So this guy, the circumcenter, would be right there. For a right angle, a right triangle I mean, let's see where he would end up. He's actually going to end up right there on the hypotenuse. And then for a obtuse triangle, he will be somewhere outside of the circle. So there's our 3 situations where we have the circumcenter of a triangle. The next one was the incenter, and the incenter, since it's always the intersection of the 3 angle bisectors, the incenter is always going to be on the inside of a triangle. So if I sketch these as best as you can, he's in the center. This one will also be in the center. And then even if an obtuse triangle, they will all end up inside the triangle because you're always bisecting the angle, so there's really no way they could meet outside of the triangle. So in all 3 cases, the incenter is inside the triangle. So what you will do with your compass is you're going to construct what we call the centroid. So let's put this down here, the centroid of a triangle. And the centroid is found by constructing the medians for each side of the triangle. So I'm going to go over that in class, but you could do this. You could find the median of a triangle. Here's its definition. A median is the segment connecting a vertex to the midpoint of the opposite side. So you'll do your perpendicular bisector construction to find the midpoint of one side, and the median goes from a vertex to that midpoint. So we have to be careful not to confuse it with the circumcenter. If I find the midpoint of a side, he's more like here, and I'll use the perpendicular bisector construction to do that. The median goes from the vertex through there. And again, they are concurrent. If I put these markings in, that'll show that these sides are split by that midpoint. The medians of a triangle are concurrent, and where they intersect, this point is called the centroid, and it's actually the center of gravity of the triangle. You could cut this triangle out and balance it on its centroid, and it should stay pretty well balanced. Now if I were to sketch the centroid of the triangles here, if I tried to kind of sketch where the halfway point is on each side of the triangle, and then I can put my markings in to show that they are cutting that guy in half. The centroid is going to go from a point to the median on the opposite side, from a vertex to the median, from a vertex, or the median is going to go from a vertex to the midpoint, vertex, midpoint, vertex, midpoint. So the 3 blue lines are the medians, they intersect at the centroid, and you see it's inside the triangle. Same thing for an obtuse triangle. If I were to mark off the midpoints, the medians are going to go from the vertex to the midpoint, from the vertex to the midpoint, from the vertex to the midpoint, and again, it's always inside the triangle. So we've talked about incenter and circumcenter. We've just introduced centroid. The last one we're going to talk about is called the orthocenter, and what we need to do is construct the altitudes for each side of the triangle. The altitude connects a vertex to the opposite side at a right angle. So here's where we have to use our construction. We did this last unit where we wanted a point and a line perpendicular passing through a point, and if you remember, we would construct an arc, and then we can construct arcs on the other side, and that would be are perpendicular lines. So here the point would be at the vertex, and I want to construct a line perpendicular passing through that point, perpendicular to the opposite side. So you would use your compass and a straight edge to do that. If I just draw these in here, the altitude is always going to be at right angles. So there's that one, and then if I look here and I want to go perpendicular, he looks like he's going to be up there, and you'll see the third one will also work. They are concurrent. So here's a little symbol to show that these are the altitudes. And again, if you look, they always intersect in one spot. They are concurrent. So when the three altitudes intersect, it's called the orthocenter. Oops. Orthocenter. And if I sketch the orthocenter for the right triangle and for the obtuse triangle, if I do the right triangle, I want to be perpendicular to the opposite side, and from this vertex perpendicular to the opposite side. If I look, it's going to be the side of the triangle, and the same with this guy. So the altitudes where they intersect is going to be at the right angle. Now for an obtuse triangle, if I go from a vertex perpendicular to the opposite side, and I'll extend it this way. If I think about it, I need to extend my sides to do this because my orthocenter is going to intersect outside of the triangle. So we'll do some more of that in class. Remember, we have circumcenter and incenter that we've learned previously. The centroid is the intersection of the medians, and the orthocenter is the intersection of the altitudes.